We're doing a deep dive into allulose. It's a rare sugar, but it's not just about sweetness.
Not at all. The sources we looked at show it actually interacts with our mitochondria, the cell's power generators.
The tiny engines in our cells, super important for energy, overall health.
And the science suggests allulose gets right in there, working at a really fundamental level. It's quite fascinating.
Exactly. Let's talk health benefits directly linked to all this mitochondrial support. Insulin sensitivity.
Yes, that's a big one highlighted in the sources. Better mitochondrial function, less inflammation. It all seems to contribute to the body responding better to insulin.
Which is huge for metabolic health, blood sugar control.
Absolutely fundamental.
Yeah.
And related to that, reduced fat accumulation in the liver supports healthier fat metabolism overall.
Less fatty liver risk. That's relevant for many people.
For sure. And here's one that might surprise you. Exercise endurance.
Allulose helps you exercise longer. How?
Seems like it helps with glycogen storage in muscles that store energy, and it activates AMPK.
AMPK, the energy sensor switch.
Yeah, you could call it that, like flipping the switch telling your body to get efficient and use energy.
Right.
So better fuel storage, better energy signaling, could lead to improved stamina.
Huh. Never would have guessed that connection. What about the heart?
Potential benefits there too, likely linked to improving cardiac mitochondrial function, especially in contexts like obesity or insulin resistance, where the heart's energy supply can be stressed.
Makes sense. So the big question for today is how? How does it interact with mitochondria, and what does that actually mean for our health?
Okay, let's start with function. The research indicates allulose helps mitochondria, expend energy better.
Right, and it seems to help restore something called mitochondrial translation.
Yeah, basically helping them make their own proteins properly again. This seems especially important in the liver and in fat tissue.
Protein production inside the mitochondria.
Okay, and that's key for them to work efficiently. The sources also talk about NADH homeostasis.
NADH. Remind us quickly.
Think of it like a critical co-pilot for energy production in the mitochondria. It needs to be in balance.
And things like obesity can throw it off balance.
Exactly. Insulin resistance, too. Allulose seems to help nudge it back towards normal, sort of fine-tuning the cellular engine.
Okay, and is this just happening in one or two places?
No, that's what's really interesting. The studies suggest benefits across different tissues. We're talking heart, brain, liver, even white fat.
So reducing stress on the mitochondria, boosting their function generally.
Seems like it. Healthier mitochondria mean healthier cells, more energy. Pretty straightforward link there.
Uh-huh. You mentioned fat tissue specifically.
Right. There's this concept called mitochondrial uncoupling. Allulose appears to promote this in fat cells.
Uncoupling sounds a bit technical.
Think of it like letting the engine idle a bit faster to burn off extra fuel as heat instead of storing it all as fat.
Ah, okay. So potentially less fat buildup.
That's the idea, helping burn energy rather than just store it.
Interesting. Now, what about inflammation? The sources mentioned that too, right?
Yeah, definitely. It seems allulose can influence immune responses, particularly in the liver, things like chemokine signaling and macrophage activity.
So calming things down a bit.
Kind of. It appears to help dial back excessive inflammation.
And how does that link back to mitochondria? Is it separate?
Well, it's indirectly beneficial. Chronic inflammation is really tough on mitochondria. It can impair their function. So less inflammation means mitochondria can work better.
I see. So it's like creating a better environment for them.
Exactly. And there's more. Some research suggests allulose can actually reverse some negative gene expression changes caused by, say, a high-fat diet.
Reverse gene changes, like what?
Specifically genes related to oxidative phosphorylation, that's energy production and fat burning within the mitochondria.
Wow, so potentially undoing some damage at the genetic level.
Potentially, yes. It points towards a real metabolic shift. There's even mention of it helping with conditions like chronic enteritis, possibly by regulating processes tied to mitochondrial dysfunction.
Okay, this is painting a pretty compelling picture. And finally, antioxidants.
Right. By reducing that oxidative stress we talked about, it acts sort of like an antioxidant, which could offer broader protection against various chronic conditions down the line.
Okay, let's quickly recap the main takeaways then. Allulose seems to directly help mitochondria.
Improving their energy processes, helping them make proteins, balancing that NADH.
Reducing stress on them, encouraging fat burning through uncoupling.
Right. And these actions seem to translate into health benefits like
better insulin sensitivity, less liver fat, maybe better exercise endurance.
potential heart protection and general antioxidant effects by reducing cellular stress.
So the core message is that allulose seems to offer these advantages by fundamentally supporting our mitochondrial health across the board.
That sums it up nicely. It's working at a very basic but very important cellular level.
So here's a final thought to leave you with. Given these effects deep inside our cells, what other, maybe unexpected long-term benefits of allulose might we discover as the research continues?
That's a great question.
It really makes you think, doesn't it? How small dietary choices might influence something as fundamental as our cellular power plants and ultimately our overall well-being.